A contract helps you understand how the pieces of your program fit together. A contract has three parts. It has a name, it has a domain, and it has a range. The name tells you what the contract is about. For a soda machine, you might have a name soda machine, but we've seen other names like update target and make posint and plus. The domain tells you the types of things that the function needs as input. So plus needs numbers, soda machine needs electricity and money and soda, CD player needs a CD, things like that. The range tells you the types of the outputs. So not the outputs themselves, but the types. The range of plus is a number, because 3 plus 4 is 7, and 7 is a number. And the range of update target or make position is position. We'll see that in a minute. That's a place on the screen. And the range of, give me soda, if that's a function, is going to be the soda. Delicious soda. Or a range of play CD is going to be music. And you don't care which song, because it would be silly if a CD player could only ever play one song. But it will have a type that is song. So name, domain, range. Okay. Let's look at our program a little bit to see this in action. So the update target function, here's the name in the contract. The contract appears right above the definition. It starts with this semicolon here, and then you get the name, and then you get a colon to separate the name from the domain. This is the domain, has two parts, then an arrow to separate the domain from the range. This is the range, has only one part because functions only ever have one output. So here we have the name of the function, and then the names of the inputs and the types of the inputs. So the types of the inputs, this part is the domain. Okay, so update target takes two numbers, we'll call them old x and old y, and it makes a position. That's the range. How does it do it? Well, first it adds 15 to old x. Old x is a number, we know that, and addition takes a number and gives us a number. So here we've got a number. Next, we have make position, and make position takes a number helpfully produced by plus, and so we can see that plus fits together with make position because the range of plus is number, and the domain of make position has a number in this first spot. The domain of make position has a number in the second spot. That's old y, and we know that it's a number because update target's contract says so. And the range of make position is a position, which is great because the range of update target is also position, and so this all fits together. We will make a position at old x plus 15. That's 15 pixels to the right of old x, and the same old y, not changing it at all. How do we know the contracts for functions like plus and make position that we didn't write, and so we don't have the contract right above the definition because we don't have the definition? Well, one way to know those is that over here on our web page we've got this handy-dandy function reference. And if you go over to the function reference, function name, domain, input names, range, output, and what lesson you might have seen that function in. So for example, plus is right here, takes a number and a number, gives you back a number. Okay, that's a plus b. And make position takes a number and a number, makes a position for you. The type of the output, also known as the range, is a position. And in math, we would write that open paren x comma y close paren. In Scheme, we write that as make position x, y. So I hope that helped you understand a little bit how pieces of your program fit together, that the range of one sort of thing in parentheses should match a piece of the domain of whatever it's inside, and that the range of the outermost thing in parentheses in your function definition is the same as the range of the function that you're defining because, well, that's the output. And go forth and use your contracts.